Basic Electrical Safety by Greg Bog-Pellew, electrician. Let's begin with a simple but important question. Why should we bother about electrical safety? In 1997 alone, over 12,000 people ended up in emergency rooms due to electrical shocks and burns. That's not just numbers, it's real people. Even worse, hundreds of workers die each year from electrical shock. Think about this, the same amount of current needed to power a small 5-watt light bulb, yes, just 5 watts, is enough to kill 3 people. And to bring it closer to home, we had one of our own co workers injured last year by electricity. So this is not just theory, it's reality. Voltage, current, resistance. To understand electrical safety, we need to understand a few basic terms. Voltage is like the pressure or force that pushes electricity through a wire. Current, or amperage, is the actual flow of electricity. Resistance is what slows that flow down, like traffic on a road. Think of electricity like cars moving on a highway. Resistance is like traffic congestion. When there's a lot of resistance, like a traffic jam, fewer cars or current can get through. When the road is wide and clear, electricity flows easily. Current versus resistance. Now, not all materials let electricity flow equally. Metals are great conductors. They allow current to flow easily because they have very low resistance. On the other hand, rubber, ceramics, and wood have high resistance. They are poor conductors, and that's why we often use them as insulators. They block electricity. But here's something important. The human body can act as either a good or a poor conductor of electricity, depending on several factors. Factors affecting the conductivity of the human body. 1. Skin condition. Is your skin dry, wet, or greasy? Dry skin has higher resistance. Wet or sweaty skin drastically reduces resistance, making it easier for current to pass through your body. 2. Health of the individual. Certain health conditions can affect how your body responds to electrical current. 3. Duration of contact. The longer the contact with electricity, the greater the damage. Even small currents over a few seconds can be deadly. 4. Part of the body contacted electricity passing through vital organs like the heart or lungs can be fatal. For example, a shock from hand to foot may travel through the chest, increasing risk of death. Electrical safety do's and don'ts. Let's begin with some important actions that can help prevent electrical accidents and ensure a safe working environment. Do's. Keep electrical equipment away from water sources. Water is a good conductor of electricity. Even a small splash can lead to serious injury or equipment damage. Use a C-rated fire extinguisher for electrical fires. Never use water to put out an electrical fire. Shut off the power source first, only if it's safe, and then use a Class C extinguisher. Always wear appropriate PPE, personal protective equipment. Ensure you're protected from potential arc flashes or shocks. Verify de-energization using appropriate testing devices. Never rely on assumptions. Use calibrated devices to confirm circuits are de-energized. Use lockout tagout Lototo procedures. Prevent accidental re-energization by using proper Lototo practices before starting work. Maintain a safe distance from exposed live conductors. Respect approach boundaries to avoid accidental contact. Use only standard approved insulated tools, for example VDE approved. Ensure tools meet safety standards to handle live electrical components. Stay trained and certified for electrical tasks. Only qualified personnel should carry out electrical maintenance or repairs. Use earth, leakage, residual current circuit breakers, RCCBs, ELCBs. These devices help detect faults and prevent shock-related incidents. Don'ts. Remove frayed or damaged cords and equipment from service immediately. Damaged insulation can expose live wires and pose serious hazards. Never pull a plug out by tugging on the cord. Always grip the plug directly to avoid damage. Don't work on energized equipment. Always de-energize before starting any repair or maintenance. Don't wear metallic items, rings, watches, jewelry while working. These can conduct electricity and increase the risk of shock or burns. Don't use electrical equipment with wet hands or in wet areas. Wet conditions heighten the chance of electric shock. Don't overload power outlets or extension cords. This can lead to overheating and fire. Don't block access to electrical panels. Ensure panels are accessible in case of emergencies. Don't perform electrical work alone in high risk situations. Always have a buddy or supervisor nearby in case assistance is needed. Don't assume a circuit is off without testing. Always test first. Never rely on labels or switches alone. Grounding electrical equipment. Let's talk about grounding, a critical safety feature. Grounding is designed to safely carry any leaking electrical current down into the earth, preventing it from passing through your body. A grounded cord has three prongs and must be plugged into a three-slot outlet, also called a three-way receptacle. Some tools are labeled as double insulated. These have extra internal protection and do not require grounding. Always check your equipment before use. If it needs grounding, make sure the connection is proper and secure. Electrical shock injury. How much is too much? Let's talk about something many people overlook, the real danger of electrical shock. It's a common myth that only high voltage is dangerous, but in reality, it's the current measured in amperes or milliamperes that affects the human body the most. Now, let's look at what happens at different current levels. At just 0.001 amps or 1 milliamp, you might feel a slight tingling. This is known as the threshold of sensation. At 0.01 amps, that's only 10 milliamps, your muscles can freeze and you may not be able to let go of the object delivering the shock. This is extremely dangerous in real life situations. At zero point 0.1 amps or 100 milliamps, it can cause an irregular heartbeat, which can be fatal without immediate medical help. At 1 amp or 1000 milliamps, we're looking at severe burns, both internal and external. This level of shock is often fatal. Even a small current can kill, especially if it passes through vital organs like the heart or brain. So remember, it's not just about avoiding high voltage. It's about avoiding any unsafe contact with electricity. Stay alert, stay safe. Electrical shock summary. Let's quickly recap what we've learned about electrical shock. Even low voltage electricity can be dangerous. People often assume that only high voltage is harmful, but in reality, it's the current that causes injury. And even small currents can be deadly under the right conditions. Your body can conduct electricity very well, especially when wet. Sweat, water, or even damp clothing increases the risk. That's why it's critical to stay dry and use insulated tools and gloves when working around electricity. Follow the basic ground rules of electrical safety. Always use grounded or double insulated equipment, avoid shortcuts, and stick to proper procedures. These rules are in place to protect you. Never use defective equipment. If you notice a frayed cord, exposed wire, or a tool that's not working properly, remove it from service immediately. Don't take chances. Always follow safety procedures, no shortcuts. Your safety and the safety of your co-workers depends on awareness and action. When in doubt, stop and ask. Better safe than shocked. Safety isn't a choice, it's a responsibility.